Hello, and this time we're looking at solving trigonometric equations, but doing it in radians. But that's not really any different to doing it in degrees. The process is the same, it's just that the range has the values in radians, and of course our answers will be in radians. But we're still going to use trigonometric jiggery-pokery to make this solvable, and then we're still going to use a cast diagram, or as I refer to it, all students talk crap, to look at the other values. If you remember, within 0 to 360 or 0 to 2 pi in radians, a full turn, a full circle of angles, you'll get two answers for inversing a piece of trigonometry. You'll get, if it's a positive answer, then you'll get a angle between 0 and 90 for all sine, cos and tan, and then depending on which ratio you're using, the other value will either be in this quadrant, this one, or this one. So we'll come back to that. Let's look at this question in particular. It's got some squared cos and sine in it, so it looks like we're going to use the relationship that sine squared theta plus cos squared theta equals 1. And in fact, they've already rearranged this to be cos minus 1. So that looks very similar. If I move the cos over here, if I took that away, then I'd get 1 minus cos. So that's almost what we want, but of course it's the other way around. So we can do that. We can just say minus sine squared theta is minus 1 plus cos, which is what we've got here. Cos squared minus 1, cos squared minus 1. So we can rewrite this whole thing, but just replace this with minus sine squared theta. So let's do that down here. Minus sine squared theta equals 7/2 sine squared, well they're using x not theta, but there we are, so x, sine squared x minus 2. So we can bring this all together and say, let's bring the 2 over and the sine over here. So we've got 2 equals 7/2 sine theta plus, sine squared x plus sine squared x. Just adding that over, and of course we can just group this together. 7/2 plus 1 whole one is going to be 9/2. So we just add another whole one onto that and say it's 9/2. Got to get rid of this, so let's times by the 2, divide by the 9, and say that sine squared x equals 4/9. We can then square root that and get, let's come up slightly higher, and get that sine x is the square root, so it's actually plus or minus 2/3. So we're going to end up with potentially 4 answers here. And then we can just do the inverse sine. So we need to do inverse sine of 2/3 and see what that gives us. So as we're in radians, make sure our calculator goes into radians. So shift, set up, angle unit, radians, shift sine of 2/3, and we get the answer of 0.729 or 0.730 if we round it. Now this gives it positive because it was giving positive 2/3, so this is giving an angle here, and this makes sense because this is less than half of pi. So the other place where we're going to get a positive value for sine is on the other side, the same distance but away from pi. So to get the other value, we're going to have to say what is pi minus that answer, and so the other correct answer should be 2.411. Let me just check if that rounded. Oh yeah, a 2 at the end. Okay, to round that. But of course, we could also have done, sorry, I just realized sine to the minus 1 there. We could also have done the inverse sine of the negative answer. So sine to the minus 1 of minus 2/3. Okay, and let's see what that gives us. So go back up and put a minus sign on there, and we've got minus 0.72 which is the same amount as we had before, but underneath the axis. But we can't have that. We're going from 0 to pi. So we actually want the angle that goes all the way around to there rather than negatively down. We need to go the correct way around. So what we want to do is just add a full circle onto that. So we add on 2 pi, and that should give us the big angle all the way around. So this is 5.55. Let's put the 3 on. I seem to be doing it to 3 decimal places, not sig fig, but it doesn't matter. So that's our first answer. And because this sign gave us a minus answer, that's why we're in the C. Yes, because remember, these letters tell you which trigonometric ratio gives a positive answer in which segment, not segment, in which quadrant of the graph. So all of them are positive here, and sine is positive there. That's why we took our 2 positive values here. But this sine of x gave a minus 2/3, means we need to be in the 2 quadrants which are negative for sine. Well, this is one of them, and this is the other. We know that because they are positive for tan and cos, and therefore sine is negative. So we've got the first one. We came all the way around into this quadrant and got this angle, and we want the same distance, but we want it from pi. So what I'm going to do is I'm going to go back to this value here, although I want it to be positive. So I had that here. There we go. So it's that angle here that we've been working on, but it wants to be more than half the circle. So that's why I needed it to be positive. So it's that amount plus a whole pi. So we have pi going there, and then that angle coming around, and the answer is 3.871. So there are 4 answers to this question, and that's because we had this squared. We normally get 2 answers, but the squared meant that there were answers for the 2/3 and answers for the minus 2/3. And if you think about how the graph would look for sine, it would normally look like this, and there'd be your 2 answers there. But because we've squared it, it's going to look, well, actually, I'm not sure it does grow, does it? It's not going to grow any taller, but it is going to probably be a bit wider and flatter. And then the second one is now positive, because when you square negative numbers, they go positive. And so here you can see that there are 1, 2, 3, 4 answers, and those are them in radians. But notice I'd have done exactly the same thing if it was in degrees. It's just that would have said 0 to 360, and when I did all of this, it's completely independent, and it's just at this stage that I would have said, inverse the sign, and my calculator would have been degrees, not radians. So it shouldn't make a big difference to you doing it in radians, just as long as your calculator's on it. The method is exactly the same if you were doing it in degrees. If you have any questions about that, then you can let me know in the comments, but otherwise, ta-ra for now.